Hello, good morning, everybody. I hope you are all doing well. My beloved students from grade 10A and 10B. 1 week and I started already missing you all. I hope you are all doing well. You are safe. Hopefully things are going to get settled down. Things are gonna be alright and we'll be back to school to see each other. Alright, let's continue with a new chapter. Today I'm going to chapter number 15. And I'm going to deal today with central angles and inscribed angles. So in this chapter, basically, we are going to talk about geometry related to circles. All right, let's give some definitions here. A chord is a segment whose endpoints lie on a circle. Take an example, AB here. We call AB a chord. So the chord is any line or a segment, okay, that has or that cuts the circle in 2 points. BD also is a chord. Why? Because it crosses the circle in 2 points. AB here is a chord as well. BD is a chord. What about CD? No, it's not a chord, of course, because it's only touching my circle in 1 point. There is no other point from the other side. So this is not a chord. Okay, AB and BD in both circles are chords. We also have what we call central angle. It's an angle with the measure less than or equal 180, okay, whose vertex lies at the center of the circle. So the center angle is the angle that has the vertex exactly in the middle or in the center of my circle. Here, ACD, this angle, is a central angle. ACD here also is a central angle. We have another type of angles in the circles that is called inscribed angle. Okay, it's an angle that has a vertex not in the center, but it's in the perimeter of my circle. For example, ABD is an inscribed angle. So it is the angle that has a vertex, lies on a circle, and whose sides contain chords of the circle. So the inscribed angle, its sides are chords, whereas the central angle, its sides are not chords. In fact, we call them radii in plural, but in single you say radius. Okay, this is radius, this is the chord. This is a radius and this is a chord. All right. Also, ABD here is an inscribed angle. Why? Because its vertex lies on the circle, not in the center. That's the main difference between central angle and inscribed angle. Okay, talking about arcs, we have types of arcs. First, what is the arc? We call this AB, this curved line here, we call it arc. And notation for that, we write AB with a curved line on the top. This means the arc. All right. What is the measure of the arc? It's the measure of the central angle that the arc is in between. For example, if this angle here, ACB, the measure of the angle ACB is 20 degrees, we say that the arc AB has measure of 20 degrees. So we measure arcs in degrees of the central angle. All right. So the first type we have is a minor arc. It's an arc whose points are on or in the interior of a corresponding central angle. For example, this one is a minor arc. It's like the small arc. here, AB. I said the measure of AB, the arc of AB, equals to the measure of the angle ACB. The other type is the major arc. It's an arc whose points are on or in the exterior of the corresponding central angle. If I write ADB, look, what is ADB? This is A, this is D, this is B. This is the central angle, and this is my arc, ADB. So we call this big arc here, we call it major arc, when it is outside or in the exterior of my angle. So AB is minor arc, ADB is major arc. We denote it again with the same notation, so ADB with a curved line on the top. So what is the measure of the arc ADB here? Easy. It's the whole angle minus this angle, right? So again, I'm looking for the measure of this arc, ADB, only this one. So it is what? It is the total arc or the total angle minus the minor arc. So it is 360. We know that the angle, the total angle that is in the circle, it is 360 minus the measure of the arc AB gives me the measure of the arc ADB. So measure of ADB equals 360 minus the measure of the angle ACB, or the measure of the arc AB. All right. Semicircle is an arc whose endpoints are the endpoints of diameter. We call ADB here a semicircle when its ends A and B are lying on the diameter. This is the diameter. The diameter passes through 2 points of the circle and passes also through the center. So this arc here is a semicircle, or half of the circle. What is its measure? Very clear. It is straight angle, so it is 180 degrees. Now, we have a postulate of arc addition. In a circle where I have 3 points ADB and the center C, the measure of the arc ADB, where is ADB? So the arc ADB, the measure of this arc here, equals to the measure of the arc AD plus the measure of the arc DB. All right, it's addition. So two adjacent arcs, okay, their sum is equal to the total arc, which is AB. So the measure of AD plus the measure of DB equals to the measure of AB. All right, this is a postulate. In fact, when we say postulate, it means we do not prove it. Okay, we take it as it is. It's a basis. Understood, Safa? Okay, let's take an example. If the measure of the arc GK is 27 degrees, where is GK? GK is 27 degrees, this arc here. Determine the measure of NP, of the arc NP. I'm looking for this arc here, using the appropriate theorems and postulates. Here it says MK and NG. This denotes what? Lines. So the line MK and NG are intersecting at the center of my circle C. Alright, how can I find the measure of NP given GK? We start from the arc GK. Since the arc GK is 27 degrees, then the measure of the angle GCK, this angle, has the same measure, so which is 27 degrees. Now, this is 27 degrees. Look at the angle MCN. MCN. What can you say about it? It should have the same measure at this angle, right? Why? Because they are vertical angles. This is 27. This angle also should be 27. Alright? Now, I have that the measure of MCP is 90 degrees. MCP, this total angle is 90 degrees. Why? I have here 90, so this should be also 90. Then, what is the measure of the angle NCP? It is 90 degrees, this total, which is MCP, minus the angle MCN, which is 27. So 90 minus 27 is 63 degrees. The angle NCP has 63 degrees. Now, what is the measure of the arc NP? The arc NP has a measure that is equal to the angle NCP, which is equal to 63 degrees. Alright, we've used the arc addition postulate. The total arc is 90. The small arc is 27. What is this? It should be 90 minus 27, which is 63 degrees. Let's take another example here. Look, these are two clocks. The minute hand, we call it the hand here, this one, the minute hand of a clock sweeps out an arc from 3:10 p.m. to 3:30 p.m. Here, my minute hand moves from this position from 3:10 to 3:30. So the question is, what is the measure of the arc that my hand made? So first, it moved from 10 to 30. Here, I'm looking for this angle. What is this angle? It is obviously third, 1/3 of the total angle. In 60 minutes, my hand moves 360 degrees, right? In 20 minutes, it will move third of 160 degrees. What is the third of 160 degrees? It's 1/3 times 360, which is 120 degrees. So 20 minutes is 120 degrees of arc. Clear? Let's get to the last example. If the measure of EF, the arc EF, is 45 degrees, this is EF and this is 45 degrees, and the measure of the angle ACD is 56. This is ACD, this bluish color here, 56 degrees. Determine or find the measure of the arc BD. Alright, how can I find it? Use the arc addition postulate. So EF is 45 degrees, then the angle ECF is 45 degrees as well. Now, look at these two lines. They are crossing through the center, so ACB should be 45 as well, right? The angle ACB is vertical with this angle, so it should be 45. Now, this total arc has the measure of the angle ACD, which is 56. What is the small one? It is the total, which is 56, minus 45, gives me this angle, which is BCD. 56 minus 45 is 11, so this angle here is 11 degrees. And thus, the arc BD has a measure of 11 degrees by using the arc addition postulate. Easy class for today. Here you have a small homework to practice on. You have here this circle that is centered at A. You have this angle CAD 51 degrees. I want you to find the measure of the arc CE, the measure of the arc DF, and the measure of the arc DEC. Don't forget to upload a clear image of your answers to the Google Classroom. If you have any questions, don't hesitate to ask me. Here is the classroom.google.com account I created. Those who did not join yet, please do by going there and putting this code here, MEOXYX3. Alright guys, sleep tight, use sanitizers, keep yourself safe. My prayers for you all to be fine. Thank you and see you in the next class.